Hey everybody. So this is the network that I built, the enterprise network that I built for my Capstone project. And basically the needs that this is solving is a company has three different office buildings and somehow no computer network. So they hired me on to implement this virtual network in Packet Tracer using network best practices like making sure it's secure with different protocols, making sure it's efficient, there's not a bunch of packets roaming around in circles, taking up all the bandwidth, making sure it's scalable, which I've done by these switches have extra ports that computers could attach to, the DHCP pools on the routers, there's extra addresses there that new devices could utilize, and then also by making sure that it's available, which means basically if a user wants to access something and they should be able to access something, that it's available to them. There's not a lot of downtime on the network. So keeping that in mind, I came up with this type topology, which is basically a router on a stick. And what that means is that you have all these switches here that are interacting with each other through trunk ports going out up to a single router, aka router on a stick. The routers are then converging with each other through EIGRP, excuse me, and that's what's allowing the packets to flow through the network. So let's just get into some of the configuration that I've done for this. So after I came up with the topology for this, the first thing that I was concerned with was addressing. I know how much of a pain addressing can be if you do it wrong, if you either subnet wrong, or if you get the, basically if you just have address complications, it can be a real headache for you down the line. There are two really different methods that you can use for addressing. You could sit here and do a static address and do whatever there, and but you would have to implement that and sit here and go through each PC and do that. Instead, there's this beautiful piece of technology and programming called DHCP, which allows you to go in and set up DHCP pools on routers, and then those pools have however many addresses you set them up to have, and they will then assign dynamically to the PCs. So even if you were to hook up a new PC to a switch, that router, should you set up a DHC pool correctly, will go ahead and give that the address. Also, as we see here, it can give them the DNS server, which can, we'll look at that later. So after you set up, I guess I'll go in here and show the DHC pool here, give you an idea of what that looks like. So for instance, there's a DHC pool for the West admin switch here, which has a total of 254 addresses. The IP ranges from 192.168.10.1 to 10.254. It's excluded 5 addresses. That is for the virtual interfaces, or the sub interfaces, excuse me. And for I know on this one it has excluded addresses for the servers over here. So yeah, that's pretty much your DHCP pools. So basically, when you're looking at this and you're looking at, here, let's go, the West admin here, and you're looking at these PCs that it's connected to, you see that there's 2 leased, so those have both leased their DHCPs, or excuse me, their IPs. So those can come from anywhere within this range that is not an excluded address. So that's how they get their addressing in this, in my network design. So next up, let's talk about, so the routing protocol that I used, the 2 big routing protocols that you can use are EIGRP and OSPF. They each have their pros and their cons. OSPF is more complicated, but it also segments your network better. I went ahead and went with EIGRP because it converges faster, meaning the whole network from the time you boot things up, and everybody exchanging addresses and all that, doing three-way handshakes, all that neat, happy, fun stuff, that happens the quickest with EIGRP. Um, so also because we used are strictly Cisco devices. EIGRP was originally a Cisco proprietary thing, so I thought it just made more sense to use EIGRP. It's kind of what these devices were made for, I guess. So as you can see here, when I do show IP protocols, the IP protocol is EIGRP1, and that's going to be consistent across all three of these routers. This router ID is 2.2.2.2. I know, very original. Some of the addressing, or I guess a lot of the addressing, was done in more of a maybe not a way you would see in an actual implementation. It was more for ease of use and to keep track of things better. So this is 2.2.2. I know this is 1.1.1, stuff like that. In a real scenario, some of the IP addresses and the naming conventions that I use, you wouldn't want to use because you don't want to make it so obvious of if somebody's trying to hack or track down your traffic, you don't exactly want to name your switch marketing so they know exactly what switch, or your router, you don't want to name that exactly what it is. Here's your distance. And then what you're really looking for here is these are the networks that that router is the EIGRP is set up for and route to. And then these are its two neighbors here, those two links. Okay, so those are the routing protocols. I also set up VLANs. VLANs very important, can be very tricky to get right. And so basically what a VLAN does is it segments, it can segment a switch up. So rather than having all this traffic be separated, you could just say have this VLAN 10 and this VLAN 20. Maybe they can't communicate with each other, but if you have a VLAN 10 over here, these two can communicate and share information. That's a good way to segment, for instance, with this situation where you have the admins, if you just want administrators to be able to, like your higher ups, to have access to something and not all these other people, VLANs are a good way to segment out that that information. Also, they separate broadcast domains, which cuts down on congestion and network failure, all that good stuff. So I did internet routing VLANs, which require you on these routers. Let's see here. So as you see on the interfaces here, you have the physical interface, which is gigabit Ethernet 00. You also have, you can create these virtual sub-interfaces, which these virtual sub-interfaces, each of them correspond to a VLAN, and it allows VLANs to be routed to that traffic. So say if you have this 10 network here, it can go up and go to this, this virtual sub-interface, which is 00.10. And so basically that's how the VLANs function on here. Okay. Also, another thing that I have configured, I didn't do a whole bunch of them, but I just kind of wanted to talk about them real briefly, is access control lists. They are a good way to filter traffic from your network. They're not exactly a substitute for a firewall, but they can definitely support a firewall. And so for me, I did, might help if I got into the console first. I just did, hold on, I need to show access lists, right? Oh, not in the config mode, that would help. So I just did this one access list just to kind of like, hey, here's access list, give me something to talk about. So basically with this network, and this is a pretty realistic scenario, you don't want your people at work on Facebook. So basically what this is saying is this is an extended access list with its first entry being to deny IP from, this is the Facebook IP address. And so that's what this statement is saying here. You have standard and extended access control lists. Standard's much more basic, source destination IP type stuff. This, you can get really deep into it. You can block from source and destination IP, but only a certain port, like a certain TCP or UDP port, to really block certain types of traffic or block certain types of access. Then you have this second command. So after it's ran through this command, after it's blocked any of the users from using Facebook, it then goes down to this, which is just going to permit any traffic after that on the access control list. Of course, that doesn't apply to the VLANs. The VLANs still are going to restrict stuff. But as far as this access control list, all they care about is making sure that the workers do not get on Facebook. Okay, what have I talked about? Okay, so we got our servers over here, and it's always good to have a local DNS server. And so what a DNS server does, let's go ahead and look here. So what we're going to do here is we're going to go to cisco.com, and so basically when you enter that web address in there, you're not actually, the computer is not actually registering like, oh, you put in cisco.com. Like everything else, it's in numbers. And so what a DNS server does is it holds all these different addresses, and it has text that corresponds to IP addresses. So the DNS server, I write in cisco.com, and it takes that and transfers that into an IP address and allows me to get on web pages. And so you just can click around here. So the DNS server setup can allow people to get on the web. You also have your mail server here. And that's gonna exactly what it sounds like. That's gonna allow people to correspond via mail. So let's go ahead and send an email over to good old admin2. Say hi. Send that over, and this says it's successful. In case you don't trust me, we'll go ahead and go over in the email over here. That was from earlier. Let's ignore that. But this one works. This is the current one. And he says hi. So people are going to be able to mail back and forth. So yeah, basically that gives you a basic overview of what this network entails. And just so you know that we have internet connectivity here, let's see if the admin over here, PC21, can ping PC7. So we got 192, oh, one down, 192.168.100.2. So, and there you go. You get your ping back. So this is the network that I've set up. I hope I gave you guys some good information and basically good ideas as to how to set up network, different possibilities as far as configurations, and that is my capstone.